Dear ladies and gentlemen, I'd like to welcome you to my presentation about weathering impacts on the tightening behavior of HV and HR bolting assemblies for preloading for Eurosteel 2021 conference. First of all, I would like to introduce myself. My name is Christoph. I am research engineer at the Institute for Metal and Lightweight Structures of the University Duisburg-Essen in Germany. I would like to give you an overview about the content of my presentation. I would like to start with an introduction about preloading of bolted connections and pointing out the problem definition, and then coming to the main part of my presentation, the experimental investigations we conducted, including a summary about the suitability test and the tested weathering conditions of HV and HR bolts, in particular box and pellet storage for 1, 2, and 4 weeks, various temperatures and various controlled moisture conditions. I would like to finish my presentation with a summary and an outlook. According to Euro Code 3 Part 1.8, we can distinguish bolted connections in shear connections, that means non-preloaded category A bearing type connections, and preloaded category BC slip resistant connections at serviceability or ultimate limit state, and tension connections, that means non-preloaded tension connections of category D and preloaded tension connections of category E. Furthermore, as you can see here, we can make a difference regarding the preloading of the target level of preloading. Target level 1 is to guarantee structural safety of categories B, C, and E, while target level 2 is to improve serviceability. That means the non-preloaded design categories A and D can, of course, be preloaded for qualitative improvement of serviceability. That means to increase the stiffness of the bolted connection, to reduce slip, and to minimize and to limit deformations. In Europe, for preloading, we are using high-strain structural bolting assemblies according to EN 14399 standard series, for example, system HR bolts according to part 3 of this series, as you can see here. Or in Germany, we like to use system HV bolts according to part 4. You can see here bolts with a short threaded part. In order to guarantee a specified preload level, suitability tests for preloading are mandatory. But we must say clearly that actual working conditions and processes on the construction site are not covered in these standards. Also, the inferences of high and low temperatures in storage conditions are not covered in the suitability test. The execution standard EN 1090 Part 2 states that high-strain structural bolting assemblies have to be used for preloading without any changes of the lubrication at delivery condition. However, from practical experiences, we know that extreme temperature conditions and moisture have an influence on the friction and consequently also on the tightening behavior. Weathering-related bolt failures in the past resulting in cost and time-consuming failure analysis and installation interruptions. Also, studies on weathering influences on the preloading and tightening behavior could not be found in literature so far. So, the leading question of my presentation is to what extent do varying weathering impacts influence the tightening behavior of these bolting assemblies? In order to give an answer to this question and a first insight, experimental investigations were conducted at the Institute for Metal and Lightweight Structures, and the following weathering conditions were considered for testing. First, the box and pellet storage. You can see here pellet storage and here box storage of the bolting assemblies for 1, 2, and 4 weeks. Why we are doing this? We are doing this to investigate the effects of realistic weathering as a combination of temperature and different moisture conditions. Furthermore, we are investigating various temperatures which can occur on construction site, for example, -20 degrees and +50 degrees Celsius. And also we tested various controlled moisture conditions, for example, dry red condition and hoarfrost. The tested bolting assemblies were M30 and M20 HV bolting assemblies in property class 10.2 K class K1 and M16 HR bolting assemblies property class 8.8 K class K2. All tests were conducted at the Institute's own tightening torque testing machine up to 15,000 Newton meter tightening torque for bolt dimension M6 to M64, and all tightening parameters were measured and determined according to EN ISO 16047. The suitability test according to EN 14399 Part 2 to check the possibility and the suitability for preloading defines different evaluation criteria, for example the criterion of individual maximum bolt force, as you can see here, and relative rotation between the nut and the bolt delta theta 1i min and delta theta 2i min. For example, also the bolt elongation can be necessary if required. So you can see we have two main criteria, the maximum bolt force FBE max and the ductility. Here is a schematic representation of a preload angle of rotation curve with the specified preload level FPC, the individual maximum bolt force and the related evaluation criterion, and the criterion for evaluation of the ductility. Furthermore, based on the individual K value, the determination of the K value you can see here, we can also make a classification for K classes. We have K class K1 and K class K2 with different ranges for the individual K value and the scattering. So let's come to the test results of weathering unprotected pallet and protected box storage. It can be confirmed that the exposure of the HV and HRbolting assemblies to weathering deteriorates their preloading and tightening behavior. As expected, we already said this, but to varying degrees. For HV bolting assemblies, after 1 week pallet storage or even box storage, significant negative effects could be observed regarding the friction and also consequently about the criterion of individual maximum bolt force. As you can see here, the criterion is not achieved in every series, only partially achieved. The HRbolting assemblies M16 in property class 8.8 show no significant weathering influence for either box or pallet storage even after 4 weeks weathering impact. That means they have direct weathering impact of the bolting assemblies, but you can see here that there is no impact on the preloading and tightening behavior of HRbolting assemblies. So a strong comparison, a strong difference between HV and HRbolting assemblies, which can be observed here. Exemplary tightening curve M30 10.9 HV bolting assemblies as a reference test in black color, and the suitability test after 2 weeks of weathering as pallet storage in red color can be seen here. The preload angle of rotation curve, you can see clearly that the individual maximum bolt force is decreasing, and you can see here in the preload total tightening torque curve that the red curves are shifting to the right side. That means the friction is increasing and you need more tightening torque to achieve a specific preload. The test results for various test temperatures are summarized here. We can say that for HRbolting assemblies, the tightening behavior deteriorates at temperatures of plus 50 degrees Celsius, where low temperatures in some cases slightly improve the results of the suitability test. However, for HRbolting assemblies, again, no significant change in the tightening behavior of the bolts was observed. So let's come to the moisture conditions. Moisture conditions means water film on the threads, water storage and hoarfrost were investigated. We can say that none of the M30 HV 10.9 bolting assemblies reached the criterion of individual maximum bolt force. You can see here the reference test, all bolting assemblies achieved the maximum individual bolt force criterion, but for different moisture conditions they failed in every series. And for HRbolting assemblies, again, we can see that there is no negative impact on the tightening and preloading behavior. If we are focusing on different tightening methods, we can say that the modified torque method and combined method also show that the required preloads were not achieved for most parts. For HV bolting assemblies, as you can see here, reference test again or the preload was achieved, but for different muster conditions the preload was not achieved in most cases or only partially achieved, while for HRbolting assemblies you can see no negative impact on the tightening behavior. So let's come to the summary and outlook. We can say that weathering impacts should be considered carefully on the tightening behavior. We can say that HV and HRbolting assemblies must be delivered, protected from moisture and dirt, and stored in a dry and clean place. And we could show that M30 HV bolting assemblies are showing negative effects by impact of temperature, weather, and moisture, while, however, tested HRbolting assemblies surprisingly fulfill the requirements of the suitability test without exception. That means that the applied lubrication seems to be unaffected by the weathering impacts. A possible reason for the large differences in the results can also be found in the lubrication and already paired bolts, nuts and washers in as-delivered condition. So that means in the future, as an outlook, further large-scale experimental investigations are planned to get a deeper understanding of the weathering impact on the preloading behavior, and also in order to identify key parameters. The importance of suitability of suitable and weather-resistant lubrication could be shown. Thank you very much for your attention, and if you have questions, don't hesitate to contact us. Thank you very much.